My name is Marc Delcroix. I am director of the Planetary Observation section of the French Astronomical Society, and along with colleagues specified here, I will talk to you about the determination of Mars clouds altitude on amateur images and the scientific value that it can have. First, the clouds on the illuminated surface are quite often observed, of course, by probes which are orbiting around Mars, but usually it's really when they are above the subsolar point that these observations are made. So there is a real interest in amateur images observing specific clouds which are either above the limb or on the night side of the planet. And a key element that we can derive from that, which will be the main topic of the presentation, is the determination of the altitude of these kind of clouds, which can in return for scientific value give indication of what kind of composition these clouds can have. So what can we measure on amateur images? First, the apparent or projected position of the cloud. Why am I talking about apparent or projected position? This is because we have a two-dimensional image while the cloud is above the ground of the planet with a certain altitude, which is what we're trying to determine. And this cannot guess what is this altitude just by looking at one image. So this is the reason why everything is projected and not the real the position that you can measure, and also apparent or projected altitude above the limb that you can see there if a cloud is located there, or above the terminator. To do these measurements, we have a wonderful software which is quite standard among amateur in order to measure features on planets. It's called Tuples. And during the study that we made with colleagues, I worked with the author of the software so that it could, additionally to standard information like geometric information, that the software could provide these projected position values. Once we have these projected position values, we can actually feed this value or match these values with the complete set of equations, which is in the paper from Sanchez, Lavega and colleagues published in Nature in 2015, in order to calculate the actual altitude of the features. To calculate this altitude, this actual altitude, we have to make some hypotheses on the cloud position in 3 dimensions. As a first example taken from this paper, in 2012 there were some very nice observations from different amateur observers on a couple of different days, and these observations are actually represented here in the plain blue and red circles. So from these observations, we had to make an assumption on where the cloud position, actual cloud position was. And the assumption made in this paper was to say, over time, we see how the top evolves, the top apparent altitude evolves, and we suppose that when it's maximum, this is the real altitude of the feature that we can see above the limb. And this leads to this plane curves which fits the observations. How can we confirm this assumption that when the apparent altitude is the highest one, this is the real one? seems logical, but we need still have to confirm that. And this is by actually using the equations from the paper, the complete equations from the paper, for different possible altitudes in order to match the projected, the observed altitudes actually. So if we take the best observations, which are the blue ones, we said that the highest observation was at about 200 km projected cloud top altitude. If we suppose that this is the real altitude, the simulation is the dashed curve here, and the curve clearly fits well the observations that we see that there. So this confirms the assumption that the 200 kilometers is the real altitude of the feature. So this is one possibility. A second possibility, and quite different, is the one that we did with the colleagues for very good observation, but we could have a very good set of observation over time, over several hours, where we could follow some features, some cloud features that you see there over 90 minutes. And looking at the observations, which were taken every few minutes, we had really the impression of seeing clouds emerging above Mars shadow and then rotating into view. And we could follow that by eye, I would say, till they disappeared on the illuminated side of Mars. So how could we confirm this assumption? What we did was actually quite simple. We took for each different feature that was observed, the position where we first saw the feature, and we looked at that very position rotating into view and see if it would fit a cloud feature following this position. And that was actually the case. And furthermore, it was not only following the clouds, but it was really on the eastern side of the clouds which were observed. So you see that here you have a bright cloud here, and here the position is on the eastern side. Same thing for here and here. So that then the altitude of the feature is quite easy and comes directly actually from the equations. This is for the initial position, the 8th of the shadow of Mars. As a conclusion or a summary, we have seen there that amateur observations are quite useful when we observe clouds which are on the night side or above the limb. So please, amateurs, continue to provide such wonderful observations. And we have a tool for doing right measurement for that. Of course, we have to make to come up with some confirmation of the assumption that we can take for calculating the real altitude. But once we have that, it really has high scientific value. This is proven, of course, by the Nature paper. Additionally, the colleagues which co-authored this presentation also we proposed and submitted a paper for the observation of 2020, which I hope will be quite interesting. As a last word, if you have additional questions, want to discuss about that topic during the EPSC 2021, go to the corresponding Slack channel, and I will try to answer as best as possible to your questions. Thank you.